Our final video in our integration series is on rate of change problems. So we know that dy by dx is the rate of change of y with respect to x. So if dy by dx equals the function of x, then y equals the integral of the function of x with respect to x, where f of x becomes the integrand. So in this example, the population of a town is growing at a rate of 30 plus 5 root t people per year. The present population is 6,000. We want to find a formula for p, the population after t years. So the question gives us the rate dp by dt of 30 plus 5 root t. And in order to work out the value of p, we're going to have to integrate that 30 plus 5 root t with respect to t. And if we split into two separate terms, we can integrate them independently, remembering that we have to put that root t in integratable form as t to the power of a half. So when we integrate this, we get 30t plus 5t to the power of 3 over 2 divided by 3 halves plus c, the constant of integration. And we can simplify this as 30t plus 10 root t cubed all over 3 plus c. Now we want to determine a value for c, and we can do that using the information in the question. It tells us the present population is 6,000. So that means that when t equals 0, p is equal to 6,000. And we can substitute that into our expression for p that includes our constant of integration to solve for c. So 30 times 0 plus 10 times the square root of 0 cubed all over 3 plus c equals 6,000, which gives us a value of c equaling 6,000. So our formula for p, the population after t years, is 30t plus 10 times root t cubed all over 3 plus 6,000. Now there are certain relationships between differentiation and integration that it's helpful to know. And they're the relationships between displacement, velocity, and acceleration. Now, if we start at displacement s and differentiate, we get the velocity ds by dt and the acceleration dv by dt. Or we can also write the acceleration as the second derivative of the displacement. With integration, we start at a and we integrate to get velocity, and then we integrate the velocity to get the displacement. If we have a question that gives us the velocity, then we can either differentiate to get the acceleration, or we can integrate to get the displacement. So the acceleration in this example, a meters per second squared, at time t seconds of a particle moving in a straight line, is given by the formula a equals 6t minus 10. We want to find the displacement of the particle after 4 seconds, given that its initial velocity is 7 meters per second and its initial displacement is 2 meters. So the first step is to find the velocity by integrating the formula for acceleration, which is given in the question as a equals 6t minus 10. So we know that the velocity v equals the integral of the acceleration with respect to t. So we can substitute in our formula for acceleration. So v is going to equal the integral of 6t minus 10 with respect to t. And v will therefore be 3t squared minus 10t plus c. Now we need to determine the value of c in order to get the formula for the velocity. The question gives us the initial velocity and the initial displacement, and initial means that t is equivalent to 0, so t equals 0. We also have a value for the initial velocity, which we can substitute in as the value for v, which is 7 meters per second. So by substituting the t equals 0 and the v equals 7 into our equation, we get 7 equals 3 times 0 squared minus 10 times 0 plus c, and that gives us a constant of integration of 7. So our formula for velocity equals 3t squared minus 10t plus 7. Now we're being asked to find the displacement of the particle after 4 seconds, so now we need to integrate our velocity with respect to t in order to work out the displacement. So s is going to equal the integral of 3t squared minus 10t plus 7, all with respect to t. So by integrating each term independently, we get s equals t cubed minus 5t squared plus 7t plus c, because we need a constant of integration for our displacement. Now we know that t equals 0 already, and our initial displacement is 2, so we substitute s equals 2 and t equals 0 into our equation, so 2 equals 0 cubed minus 5 times 0 squared plus 7 times 0 plus c. And when we rearrange, we get a constant of integration of c equals 2 for our displacement formula. So s is going to equal t cubed minus 5t squared plus 7t plus 2. Now the question asked us to find the displacement of the particle after 4 seconds. So that means that t equals 4. So we want to find s of 4 by substituting in t equals 4 to this equation. So s of 4 equals 4 cubed minus 5 times 4 squared plus 7 times 4 plus 2, and that gives us a displacement of the particle after 4 seconds of 14 meters.